intended for learners with no coding experience. I'll aim to answer all of your questions. Welcome to this course, where you will begin your journey through data science. My name is Hillary Green-Lerman, and I'll be your guide to the wonderful world of Python. The purpose of this course is to gently introduce you to programming and data science by playing with some simple data sets. This course is intended for learners with no coding experience. I'll aim to answer all of your questions as we move through the course. In this course, you'll learn how to write and execute Python code with Datacamp, load data from a spreadsheet file into Python, and turn that loaded data into beautiful plots. By the end of this course, you'll be familiar with Python syntax and ready to learn more. While we learn, we'll be solving a mystery using data. Someone has kidnapped Baze, Datacamp's prize-winning golden retriever. The kidnapper has left clues that we can analyze. We'll use techniques like chemical analysis and letter frequency to pick the correct suspect. Before we can solve our mystery, we need to get familiar with how code is written. There are two ways of executing code on Datacamp. The first is the IPython shell, located in the bottom right of each exercise. In the Python shell, which is sometimes called the console, we can type a single line of code and use the return key to execute that line. This is a good place to experiment with new ideas. The second place we can enter code is the script editor, located in the top right of each exercise. The script editor lets us write multiple lines of code, as well as comments, which are lines beginning with a pound or hash symbol. When we are ready to execute all of the code in the script editor, we can click Run Code. When we think our code is correct, we can click Submit Answer. Now that we know where to write code, let's dive into our first concept, modules. Modules help group together related tools in Python. For example, we might want to group together all of the tools that make different types of charts, bar charts, line charts, and histograms. Some common examples of modules are matplotlib, which creates charts, pandas, which loads tabular data, scikit-learn, which performs machine learning, scipy, which contains statistics, and nltk, which works with text data. We must import any modules that we plan on using before we can write any other code. We do this at the top of the script editor. If we don't import modules, we can't use the tools that they contain. In this example, by importing the modules pandas and matplotlib, we're able to unbox the tools necessary to create a graph. In this case, pandas gives us the tools to read data from a file, and matplotlib gives us the tools to plot the data. To import a module, simply type import, followed by a space, and then the module name. Oftentimes, module names are long, so we can shorten them by using an alias. To give your module an alias, just add as and a shorter name to your original import statement. This statement will alias pandas as PD. Let's practice what we've learned using the console and script editor. Previously, you started writing Python code in the script editor and the console. You learned what a module is and how to import it. You also learned to simplify module names using an alias. In this lesson, you'll learn about variables, which help us reference a piece of data for later use. In the previous lesson, we told you about our kidnapped golden retriever, Baze. To solve the mystery, let's start by filling out a missing puppy report. In order to file the report, we'll need to record some information about Baze, such as his height and weight. In Python, we will represent each line from the missing puppy report with a variable. A variable gives us an easy-to-use shortcut to a piece of data. Whenever we use the variable name in our code, it will be replaced with the original piece of data. In this case, one of our variables is name, and its value is Baze. Another variable is height, and its value is 24. We define variables using an equals sign. When defining variables, we need to follow a few rules. Variables must start with a letter. You can use a capital letter, but we usually use lowercase. After the first letter, we can use letters, numbers, and underscores in our variable name. We can't use special characters like exclamation points or dashes. Variable names are case sensitive, so these two different ways of typing my_var would be different variables. On the left are some examples of valid variable names, and on the right are some examples of invalid variable names. Let's see what happens when we try to use an invalid variable name. The variable Baze-height is invalid because of the hyphen. When we try to enter it, we will receive a syntax error. Above the syntax error, we see the line of code that caused the problem, and a caret that indicates approximately where the problem occurred. Variables come in many flavors. Two important flavors are floats and strings. Floats represent either integers or decimals. Strings represent text and can contain letters, numbers, spaces, and special characters. We define a string by putting either single or double quotes around a piece of text. It's easy to get errors when working with strings. If you get one, there are two likely causes. You might have forgotten to put quotation marks around your string. If you do this, Python will think that your string is a variable, and if that variable wasn't previously defined, you'll get a name error. Alternatively, you might have started your string with one type of quote and finished with a different type. If you mix single and double quotes, you'll get a syntax error. If we want to know the current value of one of our variables, we can use print. We simply type the word print and put our variable name inside of the parentheses. When we execute the code, the value will appear in the console. Remember, the variable name is not a string, so we don't put it in quotes. Now that you know how to define and display variables, let's practice. Previously, we learned about variables, which allow us to store information for later use, strings, which represent text, and floats, which represent numbers. Now that we know the basic data types in Python, we'll start using them with functions. A function is an action. It turns one or more inputs into an output. In this example, the function is called turnOrange. The input is a shape, such as a blue square, and the action is to color the input shape orange. Consider the following code snippet. In a previous lesson, we learned that this code would read some data and produce a graph. In this snippet, there are three functions. pd.readCSV turns a CSV file into a table in Python. Plot.plot turns data into a line plot. And plot.show displays the plot in a new window. Let's learn about functions by examining one of our code snippets. This function takes the data from the table in the bottom left plot and plots letter index on the x-axis and frequency on the y-axis, resulting in the graph on the bottom right. First, let's look at the function name. The function name has two parts. The first part tells us what module the function comes from. In this case, it's from plot, which was the alias we used when we imported matplotlib. The second part, which comes after the period, is the name of the function, plot. After the name of the function comes a set of parentheses. The inputs to the function will all come inside of these parentheses. Positional arguments are one type of input that a function can have. Positional arguments must come in a specific order. In this case, the first argument is the x value of each point, and the second argument is the y value of each point. Each argument is separated by a comma. If you forget the comma, you will get a syntax error. It's good practice to put a space after the comma, but your code will run even if you forget that space. Keyword arguments come after positional arguments, but if there are multiple keyword arguments, they can come in any order. In this case, the keyword argument is called label. After the equal sign, we've put the actual input to the function, which is ransom. Eventually, this argument will let us create a legend for our graph. Before you start practicing, let's discuss two common errors for functions. If you get a syntax error, you might be missing commas between each argument. Both positional and keyword arguments need to be separated by commas. Alternatively, you might be missing a parenthesis at the end of your function. While you write code, syntax highlighting in the script editor will help remind you to close your parentheses. Let's practice what you've learned by making a few graphs.